Hello all, welcome to the series of Network Security Essentials. So in this session, we will see one more method for detecting the multiple errors, that is a CRC, named as a cyclic redundancy check. So this is one of the extended version of checksum algorithm which uses the polynomial function as an extension. So in this case, whatever data is there, that data along with the redundant CRC values we need to send to the receiver. So in that case, only receiver will identify whether there is a error or not in the data. Okay, means let's consider here my data is M. Okay, and data is M. Along with the data, as I mentioned, redundant CRC value we have to send to the receiver. So if we are sending this one, in that case only the error can be detected and checked. Otherwise, if only we are sending the original message, so it is little bit difficult to check the errors from the message. So that is why redundant, R means redundant CRC values or CRC bit values will be added into the original data. Okay, so see here, see one example is given along with the data and polynomial equation is given. Sometimes in a question you will get this direct data which is there in the binary format, and sometimes it is given into the polynomial format. So whatever data or whatever equation is there, that we have to firstly convert into the binary format. But here in our case, our data is already there in the binary format, that is the dividend. Okay, so that dividend data is already there in the binary format. So here I'm writing 1110. This is our original data. So sender, at the sender side, sender will append some redundant values, some redundant value. So how to add and how to check how many values should be added. So which is based on this equation. So in equation, highest value is a x cube. Okay, so that means we have to append three zeros at the last of data. Okay, so here I'm adding these three values which are the appended values, or in some cases if I'm having x to the power 4, x to the power 5, so our value appended values will be 4. If it is x to the power 5, appended values or zeros will be 5. But in our case, equation is saying that x to the power or x cube, right? So 3 value is the highest value from this equation, so that is why we have added this 3 value. Now, as I mentioned, whatever data is there, we have to convert into the binary format. So this equation will be firstly converted into the binary format. X cube plus x plus 1 is our polynomial equation. Now we have to convert into the binary format. So for that purpose, we need to find out the coefficient. Okay, so x to the power x cube, the coefficient is a 1 for x cube, plus x square is not present, so 0 will be the coefficient for x square, plus x is there, 1 will be the coefficient for x, and 1 will be as it is, that is x power 0 into 1. So output will be 1 for this one 0, for this one 1, and for last one 1. So this is our converted divisor. Okay, so divisor is added here 1011, right? In the divisor, based on this equation, how many bits are there? Total 4 bits are there. 1, 2, 3, 4 bits are there. So through this divisor also we can check how many values need to be appended. Okay, so here divisor is having 4 values, minus 1 we have to do. So output will be 3. So 3 zeros already we have appended. If data is there in the binary format, so total value minus 1 output we have to add into the data. Okay, now so this divisor and dividend we have to solve here now. So here I will add this divisor below this one, because if 0 is there, we have to consider only the values from 1. So 1, 0, 1, 1. Okay. Now what to do about this? We have to XOR. So XOR is saying that if value is 1, 1, so we are getting 0. If value is a 0, 0, value is a 0, 0, that means we have to write also 0. Okay, if 1 0 then 1 or 0 1 1. Okay, so here 1 1 0 1 0 1 1 1 0 1 0 1. So this is our divisor. Okay, now we got this reminder, that is a 1 0 1. Okay, so 1 1 as mentioned 0, 1 0 is 1. Then here in our data 1 1 is 0. Okay, now in the second step we have appended this value. That value we have to again add, because our divisor is having 4 bits and here our divide remainder is having 3 bits, because as I mentioned we don't have to consider the zeroth values, first zeroth values, so we have to start from the 1. So our divisor is 1 0 1 1. So for this last one we have to add this 0 here. Okay, now again we have to follow the XOR 1 1 0 0 0 0 1 1 0 1 0 1. Now again, so this 0 will be added here. Okay, and last 0 will also be added, so that will not be divided by this divisor, so that is why we got this reminder. Okay, 1 0 0. Okay, so 1 0 0 we need to append with the data, because we have added 3 zeros, that is our appended values. So while sending last 3 digits we have to append with the original data. So our now data will be 1 1 0 1 0 0. So that data we are going to send to the receiver. Okay, so at the receiver side, receiver will also follow the same step. Okay, so here a receiver will also use the original data, received original data. What is the received original data? 1 1 1 0 1 0 0. And divisor will also be applied same, that is a 1 0 1 1. Okay, again we have to follow the same step, 1 0 1 1. All right, so below this information we have to do the same procedure. XOR the function, 1 1 will be 0, 1 0 1 be 1 0 will be 1, 1 1 will be 0, 1 0 will be 1. Okay, now again this fifth value we have to add here, because our divisor values are having 4 values, right? And here 3 values were there, because we have to start from the 1. So this 0 will be excluded from this remaining calculation. Okay, now 1 0 1 1 will be added. So 1 1 again 0 0 0 will be 0, 1 1 will be 0, 0 0 will be 0. So here we we have added, again we have to add the 0 from the value, but here we are not having any output which is started from the 1, so it will be added as a 0. So at this stage there is a no error detected, because we are getting output is a 0. Okay, if the reminder is 0 at receiver side, at the receiver side if we are getting the 0th reminder, means there is a no error in the data. Okay, if a reminder is getting something different than the 0, then there is a error in the data. Okay, so for your understanding you have to solve this equation. 1 1 0 0 will be your data. Okay, and that data we have to divide through this polynomial equation. Same polynomial equation you have to use, and you have to check whether there is a error or data or not. You can put answer in the comment box. Okay, thank you.